So the distributive property is a property that many students come into class with the familiarity of, but regardless, we will spend a couple minutes reviewing the distributive property just to make sure that we fully understand what's going on. So the distributive property, first of all, can be represented by the expression A parentheses B plus C equals AB plus AC. Essentially what's going on here is we're taking this term on the outside, this term known as A, and we're multiplying it by B, which gives us AB, and we're multiplying it again by C. We're distributing it to get AC. And those two products are being added together. So these are equivalent, okay? So that's really important to understand because that's what that means. These are equivalent. They're equal. So if I have values for A, B, and C, whether I put those values in on the left side and follow order of operations or put them on the right side and follow order of operations, I should get the same result. So oftentimes when the distributive property is presented to you, it's first presented visually by way of rectangles and area of rectangles. So I have a rectangle here. For the purpose of this video, it's colored. I know your notes it won't be, but you can see that there's a blue rectangle, there's a red rectangle, and collectively they make up a bigger rectangle. So there's really three rectangles here, a small red one, a medium blue one, and the collective large one made up of the two. And what the distributive property essentially confirms for us is that if we take an expression that represents the total area, it is equal to the sum of the partial areas. So if we think about this rectangle, we know that area equals length times width. And I'm going to call, and it doesn't really matter which is width, which is length and which is width. By the way, we can also say area equals base times height. So if I'm going to call all of that my height, I guess I'm going to call that my base. So one way I can represent the total area is by saying the base, 5, times the height, which is a combination of x and 3. That's my entire area. Now, if I want to see it pulled apart, then I can say it's equal to the area of the blue, which is a base times height, 5 times x, plus the area of the red. Now, don't forget, the height is going to be the same of the entire rectangle, which means it's the height of the blue. It's also the height of the red. So the area of the red can be represented as 5 times 3. Now, I understand we should all be looking at that and saying, hey, we can simplify this, can't we? So sure, we would do any simplifying that we can. So in the case of the 5 times 3, we know that's 15. To go along with the 5x, that since I don't know what x is, all I can do is represent the blue area algebraically with the variable still included. And I can say collectively that 5x, the 5 times the x, plus 15, the 5 times 3, the two individual areas, is equal to the original total area of 5 times the entire, what I label as the height, x plus 3. So you can see we simply took that 5, we distributed to the x, is my 5x. We took that 5 again, we distributed to the 3. That was my 5 times 3, which is my 15. So it's a fairly simple property for us to exercise. It's essentially just taking a term that's on the outside and distributing it to the inside terms. What I mean by the inside terms is the terms that are inside the parentheses. So let's do some quick practice. We have 3 different expressions here, and these should be fairly quick and simple for us to work through. So the first one's very straightforward. You notice the outside term is where I want it to be to the left of the parentheses. And my inside terms are nice and simple in terms of being added. So I just take that 9 times n. That gives me 9n. And I can say it's plus whatever the result of 9 times 7 is. Now, I don't need to write the 9 times 7 only to bring it down to the result of that. I can just do in my head 9 times 7 is 63. So that tells me that the original expression, 9 times the sum of n plus 7, is equivalent to 9n plus 63. So that's your distributive property at play. If we do the distributive property on the next example, you notice something's a little bit different. This outside term, this value of 3, is to the right of the parentheses. So what we want to be in the habit of doing is following order of operations. If you think about order of operations, we're essentially using multiplication here, aren't we? And that's really important for us to understand as well. The distributive property is using the operation of multiplication. And I'm using that multiplication twice, right? We saw once here, 9 times n. We saw a second time, 9 times 7. And then we're just showing the sum of those two products. So if you think about order of operations in which multiplying in this case shows up more than once, we should keep in mind the left to right rule. So I'm going to make a far jump, and I'm going to start by saying 9 times 2c. I'm sorry, 3 times 2c. Well, I know 3 times 2 is 6, so 3 times 2c should simply be 6c. And then I move to the right, so I take the near jump and I say plus whatever the product of 3 times 11 is, and that's 33. All right, so this one's a little bit unique because I want to go left to right, okay? And that's our end result there. And once again, if I had a value of c, and I want to test that these are equivalent, I could put that value in for c up here. I'd have to multiply by 2, add the 11 to it to take care of everything going on in my parentheses, then multiply that outcome by 3. Versus down here, I'd have to multiply that given value of c times 6, then add 33. Okay? So we'll do one more, and this one's a little more unique because now I have a negative sign and I have subtraction going on as well. So this is where we want to be a little more careful of the signs. So think about what's going on here. This is really saying negative 8 times, and I'm going to use keep change opposite here. I'm going to say 3x plus negative 9. So I'm going to show that this is keep change opposite. So I want to see very deliberately that this is a negative 9 that I'm going to distribute the negative 8 to. So if I start with negative 8 times 3x, we should quickly see that's negative 24x, right? And then I'm going to carry my plus sign down because I did keep change opposite. And now I'm going to take that negative 8, and this is where we have to be careful. I'm not multiplying it by positive 9. I'm multiplying it by negative 9. So negative 8 times negative 9 is going to give me positive 72. So we have to be more careful of the signs here. So careful with the signs is what I'll say on this. Careful with the signs. Now, I'm going to spend one last minute talking about this one because we don't have to go through this trouble of keep change opposite. If you think about this, I know it's a subtraction sign, but when I distribute it, if I think of it as a sign of that number that follows, which is what we did here, right? We thought of it as negative 9. And I can do negative 8 times 3x. There's my negative 24x. And I can do negative 8. Now look at, I'm going to think of this as negative 9. A negative times a negative, based on our multiplication rules, that's an even amount of negative, should give me positive something. So there's where my plus sign shows up. Plus, I got to go back because I lost something earlier, plus 72. Okay, so we'll do that one more time. Negative 8 times 3x, negative 24x. Negative 8 times negative 9 gives me positive, or in this case, plus 72. Okay, so that's the distributive property at play. So real quick, let's just make sure we summarize our simple rules. First of all, move, left to right. Move left to right in your multiplying. with the multiplying. So that's regardless of whether the number is to the left of the parentheses, which makes it a natural move, or to the right of the parentheses, like we saw in this middle example, where we forced ourselves to make the longer jump first. And second of all, recognize, whoops, let's try that again, recognize the signs. And apply rules for multiplying real numbers. So that just simply means when you have a negative times a negative, make sure it shows up as plus. When you have a negative times a positive, make sure it shows up as minus. Okay, so those are two quick rules. So that's the distributive property. We will definitely investigate this more in class and get some good repetition in, and we'll move on with our further discussion of simplifying expressions from there. See you then.